Okay, students, now we are going to start with the PYQ, previous year questions of D&F block. Already we have studied so many lectures regarding the D&F block, complete detailed lectures and one short lecture. Now it is time for checking your preparation up to the previous year question or not. Okay, let's start with one by one question with detailed explanation. Okay, students, this was a surprising question which occurred in the online April 2017 on the 9th April. Okay, this was the online exam conducted on the 2017 April 9th, and most of the students were not worried about the manganese because manganese was not considered as less reactive metal, but you should worry about the oxidation state also. Manganese with positive SRP, in the +2 oxidation state shows that it will not liberate. Okay, so any metal with negative SRP, if SRP is negative, then what it will do? It will start liberating the hydrogen because it will lie above the hydrogen in the reactivity series. Therefore, answer to this question is D, Mn2 plus. Mn2 plus, what is the reason? Mn2 plus have positive SRP. Any metal with positive SRP will be less reactive than the hydrogen. Okay. Okay, next question is the reaction of zinc with dilute. And concentrated. Okay, both reaction you should give nitric acid respectively. See, if we use the dilute nitric acid, then N2O will be produced. If we use the concentrated nitric acid, reddish brown gas of NO2 will be produced. So according to this, C option is correct. Okay, next question. Which one of the following species is stable in aqueous solution? Which of the following species is stable in aqueous solution? This is a question from online April 2016. Mostly you will find offline paper, but this is online paper. Which one of the following is stable in aqueous solution? Cr plus 2, MnO4 2 minus, MnO4 3 minus, and Cu plus. Okay, here actually manganese can be existing at +7 oxidation state also. This is manganate. There are two oxidation state, manganate and permanganate. If Mn is at +6 oxidation state, it is called manganate. If it is at +7 oxidation state, it is permanganate. Okay. Now presently in the B option, manganate disproportionates in neutral or acidic solution to form permanganate and manganese dioxide. Okay. Therefore, answer to this question is B. Now let's see the next question. You can try on your own. Okay, this is just a memory based question. Both will contain chromium +3 only. Both will contain Cr +3 only. Actually, ruby is related to aluminium 3+. Ruby is related to what? Aluminium 3+. Okay, and emerald crystal are composed of beryllium and aluminium. Okay, so in this aluminium, if you want color, then it will be replaced with chromium. Okay, so answer will be C. Answer is C. Both will contain Cr +3 and Cr +3. Okay, next question, memory based as well as solving. Chloro compound of vanadium has only spin magnetic moment of 1.73. Okay, 1.73 is the magnetic moment. Formula for the magnetic moment will be n into n plus 2. Okay. So it is 1.732 is 3. So that means it is root 3. Accordingly, you can find out the number of unpaired. Then vanadium chloride. To get these many unpaired, what should be the oxidation state of vanadium? Okay. This is a question from the April 9th, 2014, but it is online. Okay. So let's see who will answer fastest. Calculation also you should be smooth and fast. Okay, here I am explaining, listen carefully. So 1.732, that means square root of 3. So when I put number of unpaired electron as 1 into 1 plus 2 root 3. So there should be one unpaired electron. Vanadium atomic number is 23. So it will be 4s2 3d3. Okay. So to leave one unpaired electron, it should possess the plus 4 oxidation state. Then these two electrons will be removed and two electrons will be removed. Then it will be left over with 3d1. Okay. Answer is option is B. What is the correct option? Option B. Now you can try upon the next question. Which of the following arrangement does not represent correct order of property? Correct order of property stated against. That means paramagnetic behavior is this is correct, ionic size is this correct, or aqueous solution is this correct. Like that you have to identify. Okay, the correct arrangement. The correct arrangement about this. The correct arrangement about this is incorrect. Sorry, you have to tell does not represent, incorrect. Okay. So in the A option itself, it is incorrect. It is just because of the iron. Okay. Even though iron contains 3d6, but magnetic behavior depends upon the number of unpaired electron. So in the 3d6, what happens? Once I start filling the 6 electrons, one electron will pairing takes place, so 4 unpaired will be there. So because of this, instead of having more paramagnetic nature, it possesses less paramagnetic nature. So because of this Fe2 plus placement here, this total property arrangement is not correct. Okay. Okay, students, now let us see the next question. An element with which of the following outer electronic configuration may exhibit maximum number of oxidation states. Like it is of the 3D series only. In 3D series, in my one shot lecture also, I have clearly shown the oxidation number chart like this. Okay. The very purpose of that chart is only to emphasize these type of questions. Okay. At the center, you will find maximum number of oxidation state. That I have emphasized that. That's why all of you must go through the one shot lectures. Okay. One shot lecture, in that only description box you will get the detailed lectures. Wherever you are lagging that topic, you can choose. Okay. So which can provides you all the options to explore more marks in your any examination, right from the mains, advanced, NEET and BITSAT, also MSET, even in the board exams also. Okay, so according to that chart, I specially mentioned manganese shows maximum oxidation state, also maximum number of oxidation states. Okay, so largest number of oxidation state will be shown by this one. This is the electronic configuration of what? Manganese. So answer is A. Now let's try the next question. Which pair of the elements with given atomic number is expected to have similar properties? Similar properties depends upon the similar electronic configuration. Okay. See, you can imagine in the 2012 May 19, this type of questions are asked. Okay, answer to this question, which pair of the element with the given atomic number is expected to have similar properties? A answer. Atomic number 40 is of zirconium, atomic number 72 is of hafnium. They belong to same group, therefore they show the similar properties. They show the similar properties. Okay. So this is about the answer of this question. Okay, let us start the next question. The spin only magnetic moment of nickel 2 positive in aqueous solution. In aqueous solution, nickel 2 positive will be. Okay. So there may be twist. So try to attempt it carefully. Okay, listen now. Nickel in aqueous solution. Aqueous solution means water is a ligand. What is ligand? Water is a ligand and water is a weak field ligand. All of you are aware that what is strong field ligand or weak field ligand. Kindly go through the crystal field theory, especially three-dimensional. 3D with 3D images. I have made a lecture on that animation with 3D animation about the crystal field theory. Okay. So in that I have clearly explained water is a weak field ligand. So if it is a weak field ligand, pairing will not takes place. Okay. Pairing will not takes place. Once pairing will not take place, see, it is nickel plus 2. So 4s2, 3d8. 2 electrons will be removed and still 2 unpaired electrons are there. So square root of 2 into 2 plus 2. So then it will be square root of 8. See, it is nearby square root of 9. Square root of 9 will be of the 3 and the answer will be 2.82. Okay, now try the next question. The oxidation state of chromium in the final product formed by the reaction between, see, this is more important, Ki and acidified. I clearly explained in my one shot lecture about the KMNO4 oxidized, sorry, no, not KMNO4, it is potassium dichromate. Okay. So acidified potassium dichromate oxidizes iodide to what? Okay. So it is simple question. It oxidizes iodide to iodine. It simply oxidizes to iodine. Okay. And but question is about the oxidation state of chromium. Oxidation state of what? Chromium. So chromium will exhibit plus 6 and plus 3. So already it is in the potassium dichromate, it is at the plus 6. So final oxidation number of chromium will be plus 3. If they ask about the iodine oxidation state, that will be 0 because it will form as a I2. This is an additional information I am giving you now itself. Okay, next question is the value of spin only magnetic moment of one of the following configuration is 2.84. Okay, this is also now interrelated to the strong field ligand or weak field ligand. So suppose it is strong field ligand D5. Okay, at least with this one now you understood that how many there will be square root of 8. That square root of 8 means square root of 2 into 2 plus 2. Okay. So that means 2 unpaired electron must be. Unpaired electron must be how many? 2. Okay. So accordingly you have to select which will have the 2 unpaired electron. Let us try one by one. D5 configuration. So D5 in the strong field is different. Pairing will takes place against the Hunt's rule, like this one. See, this is the D5. But in presence of strong field ligand, pairing will takes place. What will takes place? Pairing will takes place against the Hunt's rule. So this will come over here and this will come over here. So there will be only one unpaired electron. So this cannot be like that. You can try. So in D3 there won't be any, whether it is strong field also, weak field also, pairing not required because already unpaired electron. D4. So let us check with the D4. If it is D4, no unpaired. Let me check. Okay, D4. In the D4 configuration, in the D4 weak field, there won't be any pairing, so 4 unpaired. But in case of the strong field, only this, our aim is to provide D2sp3. Our aim is to provide D2sp3. So only this will pair against the Hunt's rule. Therefore, number of unpaired will be how many? 2 unpaid. So answer will be D option. D option is correct. I hope all of you are noting down this. Very important question. Okay, students, next, which one of the following factors may be regarded as main cause of the lanthanide contraction? Cause, okay? It is just due to the poor shielding effect or poor screening effect of 4f electron by one by another in the subshell. Okay, what is the answer? Another in the subshell. Okay, this is the correct answer. Okay. Okay, this similar question we have just solved now. Lanthanide contraction is responsible for. Lanthanide contraction is responsible for. Okay. Just now we have tried zirconium and hafnium with atomic number. This was a previous question, but that time it was with atomic number. Okay. So topics are same, but way of questioning is different. So lanthanide contraction is responsible for a similar atomic radius of zirconium and hafnium. Answer is B. Okay. Note down this. Now with the questions you will have an idea. There is a tendency of repetition of concept but not question. Okay. So in the previous question we have done highest oxidation state is achieved by, but that time 3D, but here it is n-1. So answer will be D. There it was 3D5. That's why there is a very good use if you go for the previous year question solving. Okay. I think all of you will do that in every chapter. Okay, now question is from the recent 2019. These questions are staggered so that you should have a consecutive idea. Okay. So set 2 of the April 2019 about the catalyst, where iron oxide is used as a catalyst, where V2O5. Like that, if you know at least one or two, you can solve the other questions. Okay, you need not to attempt all options. Once you are confirmed that V2O5 used in the manufacture of sulfuric acid and TiCl4AlMe3, this is used in the polythene. So these two are matching. Once A is 3, these two can be correct, A and C. And B is matching with the first option. Therefore, C answer is finally correct. Okay. This question strategy is must. Don't answer everything. Okay, next question. The highest value of the calculated spin only magnetic moment among all transition metal can be. So it will be maximum unpaid can be what? D5. Okay. Among all transition metal can be. So accordingly maximum unpaid can be how much? 5. Okay. So 5 into 5 plus 2. Square root of 5 into 5 plus 2. 7 5 is 35. So it will be nearly 6. So answer will be A option 5.92. What is the answer? A option will be the correct. Next question is lanthanide ion that would show color. That would show color. This is set 1 of the April 2019. What is the answer? Answer is B. Okay. In SM will be 4F6. Sorry, 4F6, 6S2. 4F6, 6S2. Okay, here it is 3 electrons are given. So 2 electron will be lost here, 4F5. So 5 means unpaid electrons are there. Okay. So only 4F14 will be colorless. Okay. So that's why answer will be B option. There are chances are there, color will be there. Okay. So this is the correct answer. Now let's see the next question. Effect of lanthanide contraction in the lanthanide series may be by and large means. Okay. Lanthanide contraction meaning. Lanthanide contraction meaning. Okay. So answer is due to decrease in both atomic and ionic radii. Lanthanide contraction is simply it is the decrease in atomic radii of trivalent ionic and trivalent atomic state. So what is the answer? B will be the answer. Okay, due to lanthanide contraction, atomic and as well as ionic size decreases. So answer is B, decrease in atomic and ionic radii.